4 days left, so we're going to try to make the best of them that we can. I have reliable sources that have told me that today's challenge and the next two after that will be of similar difficulty to last night. So it is entirely possible that I won't finish the stream tonight because I'm going to declare a cutoff at 90 minutes and move on to going to sleep and finishing it in the morning if I do end up hitting that point. So we'll see what happens. Let me go ahead and pull up my Twitch comments as well so I have that handy. All right, so right now we have 2 minutes on the clock. I'm going to go ahead and fill out the standard boilerplate as I usually do. All right, day 22. The thing where it automatically wraps is annoying the heck out of me. Maybe I'll go fix that with the remaining minute. What is that? Is that... yep, hard wrap. I'm going to no wrap. There we go. Okay, problem solved. Now I think if I type a bunch of stuff here, yep, good. All right, 1 minute to go. Hi, Yubi-san. Oh, did I surprise you when I came on? I'm sorry. All right. So, I wonder what today's challenge is going to be. I hope yesterday was the last assembly language puzzle, but, you know, I'm open to doing more assembly language. I'm just a little tired of it, frankly. It definitely seems to be the standard motif of this year versus last year where the not hash made repeated appearances. I think at some point off stream, probably tomorrow, I'll go ahead and refactor everything to use a standard library for all of the opcodes at least, rather than having it separately implemented everywhere. And I definitely know that Eric will not be around today because Eric went to bed literally like 4 hours ago. I saw him talking on Francisca's stream. All right, day 22. Our final stop, negative 483. Okay. Well, I know I'm starting to write this. Okay. So, the depth of the case system, the coordinates of the target. We don't know the type of the region. Okay, so we need erosion levels and geologic indices. Okay. Ah, this is going to be memoization then. Yep. Got it. Cool. All right. That makes sense. So we have the mouth of the cave here. Yep. Add up the risk level. Smallest rectangle that includes 0, 0, and the target's coordinates. Perfect. Okay. I know how to proceed here. I think this should, at least part A should not take too long. It's going to be a little bit intricate, but I think that it's perfectly doable, so we'll just proceed there. Okay, we have our input, which is depth, and our target. I'm just going to not even feed an input file here, and just feed in flags. That way I don't have to do any of the hinky parts of parsing. So we have all right. Wait, depth. The total depth of the cave system. Plus the cave system's depth. Okay, yep. Okay. Okay. Target X, 13 in my input. Yep. And then 743. Okay, easy enough. Okay. Okay. I broke my syntax highlighting. Nano's syntax highlighting is unfortunately not very good. Okay, great. So we don't need to read a file. That takes away a bunch of effort. Right, so we don't need that. We don't need that. All we need is this. Great. All right, so we need to calculate some things. So what we need to do is we need to think about memoizing starting from the top left, and we're going to need to go right across, and then we're going to need to go down as we go along. And let's see. So what was that, 1010? Oh, the smallest rectangle can include 0, 0. So we can just literally go from 0, 0 to the target's coordinates. Perfect. Okay. Okay, so this is how we proceed. Target x, x plus plus, for y 0, y is less than or equal to target y. Y plus plus. Okay. So we need to keep track of, for each location, we need the geologic index and the... Okay. So in fact, I am going to not even bother actually storing this as a map. I'm just going to store this as a... So we have an integer, and then we have a, okay, something like that should do the trick. Let me think, do I want to do x's first or y's first? We'll represent as x's first, then y's first, that's okay. That needs to be initialized to 0. Actually, we can set it to target x plus 1, target x plus 1. Okay. Target y plus 1. Okay. I think that should do it. Okay, that looks fine. Okay. So... 0, 0 has a geologic index of 0. The region at the coordinates has... Okay, so something like this. I'm worrying about the conditional here, but I know that branch prediction will solve this, and it'll work nicely. So, okay. Okay. So otherwise, the geologic index will be if x equals 0, if y equals 0, knowing that we've already tested for x equals 0. So if the y coordinate is 0, then we know that it's x times 16,807, y times 48,271. So in order to be confident that this works, we need to know that we're traversing in order such that we're always going to be able to compute the result, which I think we will. Yeah, I think we will be fine. Because we'll have done the previous row above us, so we can always safely go up, and we'll have done anything to our left by the time we get to a given position, so that should be fine. I believe the memoization is okay. Okay. So finally, okay. Plus depth, oh. The risk level is what? Oh, okay. We don't actually need the erosion here, I think. We just need the type of... Well, that's fine. $21.83, that looks fine. That's going to be star depth. And those need to be dereferences of the flags. Okay. All right. That looks okay. And now the terrain. Okay. Okay. That's going to be okay. Rocky is 0, 1, and 2, which is the exact same thing as the terrain type. Okay. So we'll call this risk. Okay. Okay. Let's make sure this runs on the simple input. So, let's feed our flags in. The depth is 510, x equals 10, y equals 10. What did I do wrong here? Did I use a single quote instead of a double quote? Oh, yes, I did, right there. There we go. So it was actually the parsing that was fine. Where is terrain? Oh. Okay. All right. Oh, and that's just my keyboard repeating characters. That is 108 and not 114. Why is that? Let's try verifying that this is correct. Okay. Erosion level modulo 3. Okay. Zero plus. Okay. Oh, I messed something up. Geologic index is. Oh, it's not plus, it's times. That's why. Multiplying the erosion levels. Oh, multiplying the erosion levels, not the, Oh my goodness. Okay. Knew there was a trick to this. There we go. 114, 114, that looks good. Okay, so now let's run it on our input. That's correct. Wait, how did I get points? That's ridiculous. That was really slow. Okay. Let's go rescue. I have no idea how I got points for that leaderboard. I should not have gotten points. That was way too slow. Okay, torch and climbing gear. I can't equip both tools at once, but I can choose to use neither. Okay. Rocky regions, I must use the climbing gear or torch. In wet regions, I can use the climbing gear or neither. Cannot use the torch. Narrow regions, I need the torch, but not the climbing gear. Can move to an adjacent region, which takes 1 time. I can change gear, taking 7 minutes to switch to any piece of gear. However, if I put everything away, that only takes... No, switching to neither always takes 7 minutes as well. Okay. Yup. I see what you're doing, Eric. This is the puzzle in which you have to do a heuristic search. Great. Okay. Fine. So now, I suspect that we may wind up needing to go around the, I suspect we may need to go around rather than strictly approaching from the closest side. That is a possibility, so I'm going to compute this differently. Okay. Make sure that that works, and we're going to give it a wide berth of 10 squares on every side, just to be sure. Because I think the amount of time that I'd lose by changing gear by going an extra 10 squares is plenty fine. And if not, we can revisit that assumption, so that's okay. Fine. Okay, so I'm going to do it this way. So let me think about this. So I'm going to have a specific gear equipped. I could use a bool, but we'll do it this way. Type gear struct. Okay. Okay, so we have a place we can go as well as a we have climbing. Okay, something like that should do the trick. So, starting from a given move, we need to be able to determine where we can go. And we may as well throw a cost in here. And we are going to need to take the map of erosions, which is one of these. Okay. All right, so we can either move up, down, left, or right as normal. Or we can change our gear. But I'm not going to allow for the possibility of no-op changing our gear, I think. We can probably combine those moves. Let's think about it. Oh, no, because we have to change our gear in place, which means we need to check for what valid combinations of things can be done. Okay, fine. Fair enough. Oh, I was a fool and put my Kleenex box somewhere else. 1 second. Okay, there we are. So okay. 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 So depending upon the terrain, that determines what we're allowed to switch to. Let's see, and we know what our winning move is. So when we are at the coordinate target Y, and we have the torch enabled. So torch is going to be false true. All right. So we need to separate the costing from this. So we're going to do that instead. Okay. All right. start from 0, 0, and we start with, we start equipped. We start with the torch equipped and nothing else. All right. So we're going to all right. All right. Something like that should do the trick. Right, and so it takes us 0 minutes to get to the start. All right. I think that should work. Okay. Great. So we compute what the possible moves are, and then we can return them. Okay. So given a starting place, retreating erosion is statically computed. So first of all, we can always change what gear we have. So case 0, case 1, case 2. So that's rocky, wet, and narrow. All right. So we need a different move, which is I think part of the danger is the costs are nonlinear, so I can't do a strict flood fill, and that it's possible for a decreased cost between two nodes to decrease the the path to an existing node that we've already visited and determined a lower cost for. So I'm a little worried here about fence painting, but we'll have to deal with it. You know what? It's fine. So I think we may need something like that as well. We'll see. Okay. So, first case, rocky. If rocky, then we can use the climbing gear or the torch, but not neither. Torch and climb. We can just invert it. It's can swap these. Okay. In the case of a wet, we can switch from the climbing gear to neither. And over here we can switch to switch torch. Okay. We can also potentially move. And that will take us 7 minutes to do. Okay. The alternative is we can see what we can traverse. Okay, so we're going to let's see. Is that correct? I think that's more readable this way. No, that's more readable this way. And same for the Ys. Okay, now we check. Calculate the adjacent terrain. Okay. Same deal. Okay. Okay. So So if the terrain is rocky, then we need the climbing gear or torch. If it's wet, we must have the torch or the climbing gear, or neither, but not the torch. Okay, seems reasonable. Okay. Repeat this 4 times. Okay. So we should be able to see which ways we can go from here. Okay, so let's just check here. Moves. Okay. And we need the terrain. All right. Let's see this. Okay. That should do it. So first of all, let's just double check this. Just curious. What happens if I do this? Okay. Let's pass in the sample input as well. Start moves. Okay. Let's make sure that the options that we're given are reasonable. Okay. Risk still remains 114. Yep, that's correct. That's correct. Good. Okay. So we know that initially, starting from an area in which we have the top right, we're initially in a rocky region. So that means that we can go down. Yep, that looks correct. We can go down, or we can swap our climbing gear for or swap the torch for the climbing gear. Okay, that seems fine. Okay, great. So I have confidence that works roughly. So let's see what we can do now. Okay. So let's think about this. So I essentially want to keep track of the shortest path to each place. And if I impact the shortest path to any place, then I have to change any paths that impact it. Okay. So we're going to... Okay. Just going to set a margin here of which moves we'll consider going around. That way I can more easily control it. $20 cannot be too much more expensive, so let's try that. Okay. So okay. Oh, and that here gets changed too. Okay. So the way memoizing here works is something like that. Okay, I feel like I'm doing okay on time. All right. Okay. Actually, no. I can keep track of what to update. And that if I know that there's a shorter path to get to a specific square, then I know I need to recompute it. Okay. Okay. Fine. Okay. Okay. Now let's see this. So, going to I'm going to also assume that I'm using, that all of these things are squares at this point. Okay. So, what do we do here? Okay. And we need something to iterate over all gear types, but actually I can just do this by hand. Okay. Okay. X, Y, false. We need torch. Okay. So let's think about this. So how do I evaluate whether I can get there and at what cost? Actually, I don't need that. I don't need that at all. Okay. So for each of these squares, actually, no, I did. No, I did. Okay. Let's just enforce these conditions using the empty map as a signal that this is an illegal position. Okay. So if it's wet or required to have nothing or the climbing gear. Fine. Okay. Okay. X, Y. About how I iterate on each of these things. Okay, yes, I know how to do this. Okay. X, Y, pulse. Okay. Torch. Now okay. We don't know how to get here yet. We do know how to get here yet. Okay. So we do know how to get here, then we need to pause moves. Okay. For each okay. 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 Now I need to go. We need to populate our adjacencies list. Dependency. Okay. Okay. Okay, how do I keep track of need to short path. Okay. The climbing goes okay, I'd say. Doing pretty well. Okay. 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 Package. Copy. Okay. Okay, that seems fine. seems okay. Yeah, that seems fine. It's not the most efficient thing in the world, but it'll work. Okay. So we see a shorter way, then we record the shorter way. And then we record how we got there. Okay. Now, let's see. Now that we've done that, at the end of this, for each thing that we figure out how to get to, there is a way to shorten it. We're going to shorten it. Let's see how that might work. We need to go here. Don't know how to get here. We know how to get here. Then okay. Okay. Where was I using shortest? Okay. No, that's correct. We know how to get to our starting position. We need to record how we get to the next position. See. I'm not sure that this is small. Remember that the total square size here is the total square size here is a 13 by 743 square roughly. So there might be alternative paths that are much shorter. Because like right, if I have a fence painting problem with n equals 12,000, I'm going to have a really bad time. We'll see what happens. Okay. Okay. D. Did I define D somewhere? No, I didn't. Okay, that's what I thought. Fine. Okay. That should do it. Where'd I put the x++? Oh, thank you. Thank you, A9. We update a neighbor, then we need to keep track of the fact that we updated. Okay. Right. So might need to recompute everything in here. Let's I think that makes sense. The other way to think about it, which is considerably more expensive, is to just keep on re-resolving until we get closer. You know what? I think this is better, actually. This is simpler. I need kind of a do while. I think that this is a little bit more annoying, but this will stabilize us faster. Fine. Yep, that looks okay. 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 So let's try running it on the simple input. Stopped using that for now. Changed. Why re-declared in this proc? 11. Oh, whoops. fine. Okay. 155. Okay. Fine. Okay. Oh, that was actually okay. Oh. Right. That's okay. And finally, cost in D. 2734. 65. Oh. There you go. Okay, I think that works. Okay. Let's just print out what this looks like at the start of each iteration. That should not be happening. Actually, no, we start off by computing starting from 0. Okay. Okay. That's better. So it takes 52 moves to reach our friend, which is not correct. So why is 52 not correct here? Okay. Okay, let's think about this. Alright, let's think about exploring this in a way that makes sense. Okay. Okay, so let's think. So just want to check something really fast. Okay. I want to see how many possibilities happen after our first recomputation. So in our first recomputation, we determined that our initial position is reachable in 0, that our first, that we can change gear in 7 moves, that we can move down in one move, and that we can move right by changing gear and then moving. Wait, why is that present twice? Oh, I see. And then right, because we could get there and then we can switch gear again in 8 moves, and we can also switch gear and then move to the right. Yep, okay, that seems fine. So that seems okay. So I trust that that is roughly working correctly. I'm just not sure why it's taking 52 moves to reach our friend. Because I definitely allotted enough margin on each side to catch all of the possibilities. Think about this. Okay. Let's just simplify some of this logic while we're here. That seems fine. Let's see. How many moves does it take us to get to the coordinate? Let's see. Debugging. Debugging is always fun. Has anyone solved yet? 135 people have. Okay. So I think... Let me just actually run it on my full input. Ooh. That's a bug. Ooh. No, that's fine. Let me just see. Something really fast. This should always represent all of the reachable states. So that should be fine. That seems okay. All right, let's see. How many moves does it take us, hypothetically, in this scenario, how many moves does it take us to get to the coordinate 1, 2? Scene of 0, 1, 2, 3, 4. Coordinate 4, 1 with the false, false. So that thinks, for some reason, that it takes 19 to get there. Let's see. 1, 2, 9, 12. So that seems clearly bogus. Thanks, Moxie. I wish that I had gotten gold earlier, but you know, I'll settle for getting silver earlier. I've got 15 minutes before my hard stop, but I feel like I'm not frustrated, so I'll probably keep on going. Okay. All right, why are we not getting that value shorter? So let's find out. Let's trace even earlier. How long does it take us to get to... Let's trace that shortest path. So if I go to 0, 1, and true, false, because I think it's, no, torch first. Okay, does that work correctly? So I should relatively quickly find that only takes one move. Good, okay. So that takes one move. Okay. Now let's see how long it takes us to get to the 1, 1. Which now take 2 moves, that's fine. Okay. Now when we switch to the torch to neither tool, that should take... Ooh. That's wrong. The torch swapping in a narrow space, switching from the, wait, what's the pipe symbol? Pipe symbol is, yeah, the pipe symbol allows the torch, that's fine. Oh, there we go, that's my problem. There we go. Okay, 9. Yep, okay, now that's actually correct. Great. So let's see. Now does that work? Took 45 moves to meet your friend. That seems good. Okay. Now for some reason we think we can't reach our friend. Why is that? Okay. Oh. It's because we now have a much wider and narrower thing than before. Yeah, I think the thing that happened here was I was doing something 13 wide rather than 743 wide. Okay, but we can deal with that. So we actually do need this. Fine. Actually, that was fine as it was. But we need to do this slightly differently. Max X is going to be length of erosion 0. Plus then okay, I'm pretty confident this will return a result in time. It may take a while, but it will return a result. Great. Fine. That way we don't compute way too much. Okay. So let's make sure it works on the test input. It does. This is a little bit fence posty. I'm wondering if there's a slight optimization. I think there is. Let me just curious how we're doing. Oh, it's not so bad. Because I need to run until I get 743. So it's slowing down as it goes, but it's making sufficient progress. I feel okay with it. It's not the most efficient algorithm in the world, but it will work. And once I get the solution, I can clean it up. Actually, once I know an initial region has stabilized. I'm allowed to cheat it only in the first pass. Yep. Okay. Okay. Right, and we have an extra margin of 10. Let's see whether that's correct. That's not correct. It takes too many. Okay, so there's a better path that involves circling around, probably. Okay. I'm pretty confident this technique will work. My margins are just insufficient. So we'll try a margin of 40. The other thing that we'll try doing is we'll do this. We'll do this. Let's do this. We'll do this. Okay. Just propagate in a cascading fashion. So I can seed cleverly. That way I don't have to fence post myself to death. All right. Okay. Alright, I think that should do it. Something like this should definitely do it. Right. Okay. fine. So now we're not fence posting ourselves to death. That's still fine, that's still fine, that's still fine. Now, I think that should do it. Where do I have a syntax error? Did I indent this correctly? Hope I did. 196, of course. That looks okay. Okay. That looks fine. Why am I... That looks okay. Oh, there. Staring at me right in the face. And 156. Oh. Alright. Okay, now we're not finding our friend. Why are we not finding our friend? Start from 0. That seems fine. That also seems fine. So let's just print out what our queue is. So what's in our queue to explore? Those are all the things in our queue to explore. Right. And we explore every position in there. So our starting position, let's just double check this. Okay, so on the second run, let's just print out scene move 0, 1, 0, 1, false, true. Just make sure we can get anywhere. Nope. 0, 1, false, true. Oh, 0, 0, false, true. That should be always one move. 0 moves. Yeah, that should be fine. Wait. When does that change? No, that's always 0. Okay, that's fine. So now I'm not populating the list at all. Oh. There we go. No. Okay, that should be okay. So that should always be fine. Yep, okay, so now let's try that. Yep, okay, now that I think that works. Oh, yep, took 45 scores to reach our friend. Okay, so we don't need the debugging anymore. Max square side is %10. Okay. All right. Okay. Now let's try running it without any inputs. Still too high, but now we can safely increment our margin much higher. Ten moves. Gonna have to wait a minute, so actually, I don't even need this trick anymore. Because I'm pretty sure that as I propagate changes, I don't need to keep track of that anymore. Because I'm pretty sure... Actually, there's an easy enough test. If I just set the margin large enough, I can see whether I get any better. Nope, it's still 10-10. Okay. Haha! Got it! Rank 208. Okay. Great. I'm going to quickly see while I'm on stream, can I just always enqueue the scores I'm changing, and then don't bother with the max x, max y's. Oh, yeah, I don't think I need the max x, max y's anymore. I just need to start seeding from 0. Let me just check this in. Okay, so now I have the messy solution committed. Let's just check this without needing this. So I think I can just run this. I think I can just do this. Let's see whether that's cleaner now. Does that work now? Yep, now that works. Okay, I didn't need the square parsing anyways, because I'm just starting from the beginning. Okay, so we're essentially doing a breadth first search, but backtracking if we wind up finding shorter paths. Yep, seems okay. Yeah, let me think here. It's quicker to just always redo it than it is to not run it twice. Well, let's try this. Okay. When it's cheap to add extra margin, well, you know, why not, right? Let's see. Okay, so how long did this take? Three seconds, okay. Let's see whether this is faster. Yeah, it's faster, just unconditionally add. Fair enough. Yep, okay. That's just the way to do it. So I don't know how to decide that 150 is the correct margin. I guess the way to think about it is, how far would you have to search in order to produce a path where it was faster to go around? Yeah, no, it's fine. This is Golang, and this is an awful keyboard. Do not buy this keyboard. This is a Rocat keyboard, and it is awful because, as you can see, it's repeating characters over and over. Right. Did I use path anywhere? No, I didn't. Okay, so let's delete that surplus code that's not being used. Okay. I'm going to change move to position. Because that's cleaner. Fine. Let's change those around just to clean this up while we're here. Excellent. Cool. Let me just make sure this still works. Which it does. Great. Now let's see, what else do we do here? Why Nano? First installed Linux 15 plus years ago, and that was the one editor that had a built-in set of help functions. I got stuck in Emacs and Vim one too many times and decided I was not going to do that. Okay. Yeah, it seems totally reasonable. Cool. And I can actually move scene here. Don't need to be passing that around. That still work? Yep. Great. Okay. I think I'm going to declare victory here. Continue reformatting a few minor things, but I think we're in a good position. Okay. Okay. All right. That I think is the end of the stream tonight. Yeah, Ariel, I'm on the East Coast now, but the puzzles still release at midnight. So what am I gonna do? All right, folks. Have a good night. See you all tomorrow.